Good evening, students. So I had a couple of questions come through as I've been finishing off some of the grading. And so one of them was a student had a problem with the print function for the CLT proof. And what they were basically getting is only one iteration of the 5 when plugged into that little template that I'd showed you. So I wanted to kind of just take just a quick second, not going to take you too far into it, but to kind of show you some of the differences between the R language and the Python language. So here is an example of what the student had originally wrote for that section. And in the print function here, using this example R code, it's going into a for loop, and then it's trying to do do the string print to the file back to this naming convention. So it's basically trying to set up naming convention as central underscore 1.pdf, 2.pdf, etc. So that's again the template that I'd shared. Fire off the PDF and then do your central limit in the middle of it, and then do the dev off. By doing this, it should iterate through. Well, what this is more of a syntax, a structure that you would see in Python. And so the way that R sees this is it'll go through that iteration 1 through 5 right here, 1, 2, 3, 4, 5, and then it'll only print the last one, so central 5 PDF is what will print off. So it treats this as if you have curly braces right here. It implies that the curly braces are there. There's nothing there, so it'll just go 1, 2, 3, 4, 5, and then drop down. It's only going to give you one central PDF out the bottom of it. Now that is in contrast to the way that Python works. So here's the way that you define that function in Python. So you would still do a for loop here, for I in range 1 to 5, and then doing the PDF, doing the central limit. The curly braces are implied inside of Python. They are not in R. So that was the specific problem. When the student goes back in and added curly braces here and here, then the print function works as expected. So I don't know if anybody else had that particular problem, but wanted to share that back out as well. That's some of the differences. This is more of a Python type syntax, the way that that student had wrote it. And so just kind of watch your curly braces, because R is very literal. It'll only take the things inside the curly braces. That solved that particular problem. Now let's say I did then further ask the question of what happens if I wanted to use Python. So if you wanted to use Python, there are several different ways to do that. Now what I would say is probably the easiest way is to use the reticulate library. And here's an example of a markdown document that uses reticulate. And I will share this code back out too as well if you're interested in seeing this part of it here. So to create a markdown, you basically just say new file right here, new file, and then R markdown. It'll create one of these templates like this. So just kind of reading down through it, you can see if you use R as the starting point, this block will use an R code inside of it. If you use Python inside the block, this will create it using the Python language. And so you can switch back and forth between R and Python within a markdown document. This is quite common in actual. Now there's also several different other ways, including running out into a shell, but I just wanted to kind of show you one way to do it if you were interested in exploring this. So here it's going to fire off the reticulate command to load the library. The markdown is just going to basically print this text. The next thing it's going to do is it's going to create a Python object. That object is going to be a simple array, 1, 2, 3, 4. It's going to then print that array out. Then I'm going to switch over to R, and within R, I'm going to use the Python by doing the py $, and then refer back to the object in Python that I created. So this is a way that you could put Python code here. You could use it down here. If, for example, we wanted to take this Python code right here, we could absolutely take it and put it inside this block here, and then down within R, call it py $print function. You could do that, and then it would actually execute the Python code. So that's how you could switch back and forth between these two languages. I'll just show you a quick knit on this. And I'm just knitting it to a HTML file. Oops. It looks like I'm having some problems with my my Python installed in this particular example. But basically, it just prints this out I'll have to go back and have to double check on that one. I've been doing some updates to the Python side, and so that's probably what just caused that to have a problem. But now let's go over to all the different ways that you can do graphing. Let me clear my console. There we go. Okay, so I'll just run down through it. First of all, a basic histogram. We have done this countless times before. At this point, if you do not know how to do a histogram, I would say that that's going to be a significant issue. Hist, and I'm just going to use the iris data set. I'm going to use sepal length. If I run that, we get a plot. There's a histogram. Bar plot, the most primitive, easy way to do that is by using the bar plot command. Again, these were in the introduction examples too as well. So here I'm going to use the tree girth. I'm going to have a label called girth. I'm going to use the column of blue. If I do this, now I got a bar plot. The locator, again, was in the introduction script. And then when I click, it'll show the point. Basic box plot, same commands. There's a basic box plot. Scatter plot, by doing just a simple plot, it's going to automatically default to a scatter plot. There's a scatter plot. And the lattice library. Load the lattice library, give you an example of a sample A and a B. Use it to create a data frame, and then from that create a new element Z that'll just basically be a calculation of the two. Draw a wireframe surface, and there's also a whole bunch of other things that you can use with that. Doing the lattice right here. There's a 3D plot. So here's one that really has tripped up a couple of students. Density functions. Okay? So what I want you to do is I want you to run the help file for density, and here is a rather in-depth explanation of how density works and how building a density function. Now you're going to have to build a function around density, but this is the simple call that you would have to use as part of this. Here are all some examples. Here's all the different parameters which you can also throw to it. So you'll want to create something like this, and then I'm just going to do a simple plot on it. There's a density function. And then finally, to set up multiple rows for the CLT solution, use that parameter. So in this case here, I'm going to set up a 3-row plot. If I do that, you can see 1, 2, 3. So you'll want to set one up that is not 3. You want to set one up that's 2 by 2. So that's basically all the raw ways of doing all of the solutions for this week. You should be able to adapt that to your data, whatever data set you choose. Please do not choose the same ones that we're using here in the test example. Please do not submit this code as your solution. Either of those two will get you 0 points. Now, let's go one step further. We have a whole number of different libraries that we can use out there too as well, so I'm just sticking to base R at this point, but you could use Plotly, you could use gplots, you could use ggplots. If you're going to use Plotly, for example, here's an example using Plotly, and this just comes right off the Plotly website. There's the link right there. You can go take a look at it. Here's one that's showing a line graph with multiple lines. So if I run this, you can see that it has multiple lines right here. Now this one here, this example here shows one that has with gaps and without gaps. And the key to this is this add trace. That has, instead of creating a brand new plot, it's going to just continue to add to the existing plot. And then when you finally call back to the base, it's going to have the full graph with both of the lines mapped to it. This is one using one data set. All you simply have to do is change this over so it's using two data sets. That should be relatively simple. Now, let's say you wanted to use gplots. Gplots is another actual way that you can do this. So here I'm going to just use off of that gplots. Just use an example off of the main package. Here's the link back to the package. I'm going to go ahead and load the package. It's giving me a warning message that it's been built on a previous version, but for this example, it's going to be able to work. Let me just give a random series of 1 to 10 in a normal distribution. That's what those two are doing, so an X and a Y. I'm also going to go one more step, and I'm going to create a data frame. We've created data frames before, so none of this should be of concern there. So there's a D data frame, there's an X, and there's a Y that's been created. If I just simply call gplot and the X and the Y and use the line, gives you a raw line graph right there. And there's all kinds of other parameters that you can throw to gplot to get different types of examples. You can also use an actual data frame with it. So here's an example using a data frame, and the plot's going to come out exactly the same. ggplot is something universally used across all. Actually has a cheat sheet inside of R. So if you go here, you're going to see cheat sheets. You're going to say data visualization with ggplot right there. If you click that, it's going to give you the same example of what I've got the link to right here. So if you're going to use ggplot, ggplot is extremely simple to use as well. ggplot requires a data frame though. So one of the questions would be, when would you use ggplot versus when would you use gplots? Either would work. I would probably use gplots if I'm just doing something quick and dirty, didn't have an actual data frame. If I'm going to create the data frame, I'd probably use ggplot. ggplot has a lot more other options that you can throw to it. So it would be a little bit more robust to get more graphs, but if you're just trying to do something very simple, like just check a quick distribution, you can do that with gplots very quickly. Let me go ahead and execute these for you too as well, so you can see the graphs will basically be the exact same as what you've seen before. So that is several different ways of doing graphs. The base way in R, using the Plotly library, using gplots, and using ggplots. Now I would say I like Plotly a lot. I would tend to go more with Plotly. The calling here, the calling syntax is lined up with tidyverse, and so that's what you're kind of seeing here with the pipes that are going on right here on line 49. So I really like Plotly. If I'm not using Plotly, I'm probably going to use ggplots. Those are my two favorites. But gplots are just using a raw plot within the R. That would also be acceptable. So I'm going to share this code back with you in the announcement too as well. If you have any additional questions, please feed them to me. And if students who have kind of sent questions over the weekend, if you're still having some trouble, reach out. I'll take a look at it on Sunday too as well. Have a good one. Thanks all.